Okay, you can attempt the question independently. It deals with convergence of series. The question says, which of the following series converges? So for Roman numeral 1, there's a factorial and there's a power here. That's an, the nth term, and we're doing the sum of infinite terms. Okay. It's smart to observe the factorial and the 8 to the power of n. We can use the ratio test. So limit n approaching infinity, I'm going to do an plus 1 over an, which is limit n approaching infinity. A n plus 1 is simply, I'm going to replace every n with n plus 1. So it's 8 to the power of n plus 1 divided by n plus 1 factorial. Now I'm going to divide by the nth term, which is that guy. But when I'm dividing, it'll give you a fraction. I'm going to be dividing by a fraction. So I can just directly multiply by the reciprocal, which is n factorial over 8 to the power of n. Okay. I'm doing this to make my job easier. Okay. I'm skipping a step basically. But if you were to divide by an and you multiply by the reciprocal, this is what you end up with. The next step, I'm going to pair these terms. I'll have 8 to the power of n plus 1 over 8 to the power of n, and then I have n factorial over n plus 1 factorial. Okay. Limit n approaching infinity. Now for this guy, okay, you have a common base of 8 and the powers vary, but when you divide monomials like that with the same base, we subtract powers. So basically what's going on is 8 to the power of n plus 1 minus n, the n's cancel. So you just left with 8, the numerator. And then if you recall, n plus 1 factorial is basically n plus 1 times n factorial. So if you observed and rewrote it that way, then you'll see that the n factorials just collapse and you're left with n plus 1 in the denominator. So basically like that. And when you take infinite limits, you'll get 0, which is less than 1. Therefore, the first series converges by the ratio test. Okay. So the first guy converges. The second guy, if you observe, you have an n factorial in the numerator and n to the power of 100, which is a polynomial function, in the denominator. And if I were to apply the nth term test, the factorials, as n approaches infinity, the factorial, infinity factorial basically, will be much larger than infinity to the power of 100. In other words, the numerator rises much faster than the denominator does. In general, the factorial function has a higher growth rate than the polynomial function. It's almost like factorials rise like that, or maybe even faster, and then the polynomial maybe rises like that. But as n approaches infinity, the effect is very, very stark. Okay. So in other words, according to the n-term test, the numerator far exceeds the denominator. It's not even like close to 0. It's basically approaches infinity. But the larger point is that ratio is not 0. All right. So it's basically limit n approaching infinity, n factorial over n to the power of 100. Basically approaches infinity. All right. So since it's not 0, that guy diverges. It kind of diverges by nth term test. And the last one remaining is that expression, Roman numeral 3. So I'm going to work it out here. I could apply the ratio test, but a much faster one is something called the limit comparison test. So I'll just consider leading terms. The leading term on the top is n, and the leading term on the bottom is n times n times n, which is n cubed. So it basically, the series behaves equivalent to 1 over n squared, all right, which is actually what is called a p-series. Or I like to call this a modified p-series. In other words, we consider the leading terms, And upon simplification, we got 1 over n squared. That's like a modified P series. P is 2, which is greater than 1. So that guy actually converges by the P series test. Therefore, the original series will converge by the limit comparison test. Okay, converges by LCT, the limit comparison test. All right. I did not work out the entire limit comparison test, but I'm just showing you like a shortened version of it. So in other words, this guy works, converges, so does that guy. So the answer is 1 and 3 only, which is choice